Okay, we want to introduce the idea of the function y equals e to the x, arguably the most important function in mathematics. And you won't know why for a while, but you'll get it. Now, e is a number that's close to 2.7, which is why we constructed the graph of 2.7 to the x. That was very close to a graph of e to the x. E is defined to be the limit as n goes to infinity of 1 plus 1 over n raised to the nth power. Now, that has an interpretation in terms of compound interest. The interpretation is if somebody is fool enough to give you 100% interest and you could compound it n times a year, then your money would grow by this factor every year. And as n approaches infinity, the compounding becomes continuous and you end up with 2.718, and there's a lot more. This number's irrational. It goes on forever like pi. You end up with this number in the limit. Okay? Now, what we want to do is I just want to mention this. Okay, so your 2.7 to the x graph is very close to a graph of y equals e to the x. What we want to do now is invert the graph of a power function. So we start with our familiar graph of y equals 2 to the x. We know the points on this graph. We know our basic points. So here's our graph. Now, just take one of the basic points. Take the point 1, 2. When x is 1, of course, 2 to the x is 2 to the 1, which is 2, and you should be thoroughly familiar with that by now. If we reverse the coordinates, and by reversing the coordinates, I simply mean you switch the x and y coordinates. So instead of 1, 2, you have 2, 1. Okay. So we reverse the coordinates of 1, 2, we get 2, 1. So we plot the point 2, 1. It's right here. So there it is. So this point becomes this point when we reverse its coordinates. Now I ask people to pick other points on the graph and reverse the coordinates, and people actually did pretty well with this. People pretty much had these points out here. Not everybody got these points down here, so we need to talk about them all. But okay, take the point 2, 4. You reverse the coordinates of 2, 4, you get 4, 2. That means 4 is your x coordinate, 2 is your y coordinate. So x coordinate 4, y coordinate 2, that meets here. That point is on the graph. Now let's take a point on this side of the y-axis and reverse its coordinates. We have the point -1, 1/2. Okay, if we reverse the coordinates, we get 1/2, -1. What's that do? Well, here's 1/2, and here's -1. Right here is the point 1/2, -1 on the graph. With these points, we can do a pretty good job of sketching a curve. And the curve that emerges looks a lot like this curve, but it's kind of flipped and kind of rotated. And this part of the curve ends up going here. Well, if we follow the trend of this curve, flipping it over properly, we see it's going to do this. Where this one is asymptotic to the negative x-axis, this will become asymptotic to the negative y-axis. So there's an inverse function. Now, this function has a name. This is called y equals log to the base 2 of x. So this graph here represents the base 2 log. This graph, of course, represents the power function with base 2. Okay? Now, remember, you've done this reversal of coordinates. Okay? And I think that's one of the reasons that people did a pretty good job on this, other than just basically being smart people. You've done this for y equals the square root of x. This is how we get the graph of y equals the square root of x. We invert part of the y equals x squared graph. Now, if you don't know how to do that, well, I'm going to keep asking you. And if you don't know how to do it, you're going to keep losing points in the test. So learn to do it. There are videos. People in Czechoslovakia watch the videos. You can watch them if you don't have this. Okay. Now, just a little bit of notation about log functions. And we don't actually get into log functions for about a week. but I want you to get the overview of exponential and logarithmic functions so you can see that they're two sides of the same coin. The inverse of the y equals 2 to the x graph, as I've said here, is y equals log base 2 of x. So the inverse of the y equals 2 to the x graph is the y equals log base 2 of x graph. So what do you think the inverse of the y equals 3 to the x graph would be? Well, not surprisingly, it's log to the base 3 of x, the log to the base 3 of x graph. So if you relabel this, because you can always relabel an exponential graph for any base, if you relabel it for base 3 and invert it, you end up with a graph according to that labeling that represents log to the base 3 of x. Now, log to the base 3 of x is not particularly important. Log to the base 2 of x often is, but more often, the base 10 log or the base e log are the most important of the logs, and you have keys in your calculator for those functions. Okay, well, so, by extension, the inverse of the y equals 10 to the x graph, what would you expect? Well, you expect that to be the log to the base 10 of x graph, okay? The log to the base 10 of x function is inverse to the 10 to the x function. And the graph tells you exactly what that means. Now, the log to the base 10 of x has another name. It's log log of x, without any base. If there's no base, if there's an log without any base, usually that means it's base 10. Now, in some computer software systems, that means it's base e, because that is the most natural log. But on most of your calculators, you have an log, and that means log base 10. Okay, now y equals e to the x. Well, if you invert that, you get y equals log to the base e of x. Okay? Now, I told you that e to the x is maybe the most important function in mathematics. So the natural log function, or the log base e of x function, is very important as well, because we have to use that to solve exponential equations and stuff like that, as you'll see by the end of this chapter. Okay, so this is also has a name. It's called ln for log natural. It's the natural log, but we don't want to write nl. That would be a little more awkward than ln. We want to start it with L because log starts with L. This is the natural log. That's ln, not in, not 1n, ln. And you have that button on your calculator. So, this is an introduction to exponential function graphs, exponential functions, and logarithmic graphs. Now, there's algebra that goes along with exponential functions. We have to understand the laws of exponents. We have to understand quite a few things, but this is an overview, and we're going to be able to work within that overview.